So our M was 7.14, and our B was 37.08. So what I want to go over now, and these were a couple of questions that we didn't get to on that handout, but we need to make sure we know how to interpret the slope and interpret the y-intercept. So again, let me put these right up here. M equals 7.14 and B equals 37.08. I'm writing with a different color right now. Sometimes this black just really doesn't show up. So if it's hard for you guys to see, I guess just kind of let me know and we'll try to adapt. So I'm going to say, the first thing I'm going to say, interpretation of the slope. Interpretation of the slope. In other words, what does this slope mean? Now, when I say that, I'm asking about it in terms of the context of the problem. So interpretation of the slope. Well, first of all, we have to realize what the slope means, right? So in terms of a strategy, let's say strategy, say something about M. Well, that's what, okay, we would kind of assume that. Say something about M. Well, what does M represent? M is, remember what M represents? Remember how we say delta Y over delta X? I don't know if I used that term with you guys before, but you may remember that from high school or something like that. Delta Y over delta X, or I'm going to say the change in Y over the change in X. Okay, so we're getting there, So what I have to do, especially in this problem, for example, or whatever problem you're dealing with, we have to remember what Y represents in the problem and what X represents in the problem. Okay, now in this problem that we're considering right now, this particular problem, what did Y represent for this particular problem? Y represented what in the data we were looking at last week? Which column was Y and which column was X's in this data set?
Y was sales and X's was the foot traffic.
Very good. So I'm going to put sales up here and foot traffic down here, right? Because see, it's the change in Y. Well, whatever column Y was, it was sales. And in our example, the X represented foot traffic. So when I interpret this slope, namely when I interpret this value 7.14, right? M equals 7.14 over what? Think real carefully. 7.14, you don't really see it, but over what? Any number.
One.
Yeah. See that? Very good. Yeah, right? So this is really what the slope is, 7.14 over 1. 7.14 over 1. But look here, sales over foot traffic, 7.14 over 1. So when I interpret this slope, I need to write it in such a way in English, right, so that this 1 goes with foot traffic, and then 7.14, $7.14, I think, goes for sales. So we're going to write it like this. For every 1, here's that 1 right here. If it was a 2, then I have to put the number 2 right there. For every 1 person who enters the store. Now, where is this coming from? What I'm doing is I'm going back up to the paragraph that tells you about the problem before it enters the data. And remember, foot traffic was, I think, how many people came into your store between 1 and 2 o'clock. I think that's what it was. So so for every 1 person who enters the store between 1 and 2 o'clock, comma. So this part of the sentence takes into account the denominator, foot traffic, and the number 1. For every one person who enters the store between 1 and 2 o'clock, now I have to say something about the Y. So this part says something about the X, comma. Now, what I'm going to write over here has to do with sales and this 7.14. For every one person who enters the store between 1 and 2 o'clock, sales increase by $7.14. Okay, so again, let me say this. So this one right here, maybe I should do it like this. Maybe you can understand the color coding. If you have a different color, this may be good to do this way. 7.14 over 1. So that you can see where the numbers are coming in the explanation. So for every one person who enters the store between 1 and 2 o'clock, so here's that one right here, sales increase by $7.14. So this 7.14 is this number right here. See that? Now this 1 and 2 o'clock right here this 1 has nothing to do with this 1 right here. That 1 over there just has to do with what foot traffic means in the explanation of the problem. Because they could have said between 6 and 7 o'clock, right? So for every one person who enters the store between 1 and 2 o'clock, notice the terminology here. Sales increased by $7.14. It's not saying that the sales were $7.14. Now think about if this was m equals a negative 7.14. Does anybody see how that would change this explanation or this interpretation of the slope?
Do you hear me, Professor?
What's that?
Do you hear me?
Yes.
Okay. Would it be that sales decrease?
Very good. Very good. See, so if this were a negative 7.14 like this, negative 7.14. Now remember, when you have a negative number, that means this number up top is negative and this number on the bottom is still positive. Okay, so it's still for every one person who enters the store, right? Then you're exactly right. Sales decrease by $7.14. Very good. Very good. So interpreting the slope is rather cut and dry. As long as you know what the number is, and as long as you're clear about what X and Y are, then it shouldn't be, I mean, this is pretty much the pattern of how you write that for every, now again, if that was a 2 right here, a 2 on the bottom, for every 2 people who entered the store, such and such and such. Okay, now interpreting the y-intercept is a little bit different, that 37.08. So let's go there. Everybody had this? Everybody had this here? So I'm going to say this time interpretation of the y-intercept. Interpretation, so change this slope to y-intercept. So on the handout we were doing the last time, just make sure you write this for that particular problem from the handout last week. Now let's say interpretation of the y-intercept. This is a little trickier. Only because, and I'm going to write this data right here. You have the data in front of you. Foot traffic was, let's see, 29. I'm just writing the data right here. 49, 110, 31. And then sales was 312, 500, 799, and 102. Okay, so that was just the data. But we need to see that. So I'm going to say interpretation of the y-intercept. Okay, so we got to figure out how to interpret 37.08. This is tricky because, and you remember what we said last week about if I asked you, we went through all that drama last week and we came up with a regression formula that looks like y sub L equals mx plus b. And there was a trick question that I gave you where I said, predict sales if foot traffic is, oh, I don't know, I think I said maybe like 2 or something like that. And what we had to do first was see if that 0 value was inside of the X range. Question?
Yeah, is this data from a handout from last week or just from the textbook? I just want to pull it up in front of me.
This was from a handout that I gave on last week. So you have to look in last week's folder.
Okay.
It's
I think
like handout on linear regression or something like that.
Thank you.
All right. So I asked you to predict sales if foot traffic, and then I gave you a number that was inside of this range. Like the high value is 29, and the low value is 29, and the high value is 110. And as long as I gave you a value in that range, then you could predict. But then if I gave you a value like 15, we said the value of 15, you can't offer an official prediction because 15 is outside of this range, this X range, right? So it's the same thing that's going to happen when you have to interpret the y-intercept. Now, how do you write the y-intercept as a coordinate pair, just in general? Just in general, how do you write the y-intercept? Like I can say the coordinate of the y-intercept is 37.08, but technically, if I want to plot it, is what? When you plot any y-intercept, is what comma what? Anybody know? Like if I say plot that y,
Comma y, right?
yeah, is that comma y, and in particular for a y-intercept, x is always going to be what?
0.
Zero.
Yeah.
So if I say that b is 37.08 and I say plot it, well, it's where it crosses the y-axis. Well, the only time it crosses the y-axis is when x is 0. So say, for example, I'm going to plot, I don't know, here. So now this becomes 0, 37.08. In other words, the b is 37.08, but when I want to plot it, I have to say 0, 37.08, because that's the only way it's going to cross the y-axis. That's the y-intercept. All right? So in general, and I'm going to write this in a second, but I want you to see physically why I'm going to write what I'm getting ready to write. Anytime you have b as your y-intercept, technically is 0, b. So then when we offer our interpretation, the interpretation has to, is lodged in the fact that it's 0, whatever. You see that? Okay. So first of all, the first thing I have to do in this particular problem, true or false, 0, this x value right here, 0, is in the range of our x data. True or false? False. Right? I mean, just I haven't really done anything, but the first thing I have to do when I interpret the y-intercept is check to see if 0 is in the range of the x values. See, this 0 right here, whenever I want to interpret the y-intercept, I always have to consider 0, whatever. Now, we struggled pretty hard to figure out what this b was, 37.08, but it may be the fact when it comes to interpreting it, we may not can interpret that particular y-intercept in this problem because 0 is not in this range right here, which ends up being our particular case. So what I'm going to do is, let me write this to sort of bring it all together. And I'm going to erase this right here. So we got two things going on. We're going to say, let's say strategy. I think we did that the last time. Strategy. Check to see if x equals 0 is in the range of the x data. Why x equals 0? Why x equals 0? Because, I know, here we go. Check to see if x equals 0 is in the range of the x data. We do this because, okay, we do this because we wish to interpret 0, comma, b. We wish to interpret 0, comma, b. So the first thing I have to think about is this x equals 0 all the time. All the time. Because in general, 0, comma, b tells me what is the y-intercept. So before I offer any interpretation, I have to make sure that the 0, x equals 0 business right here, this x equals 0 is this right here. Make sure this x equals 0 makes sense. Okay? If x equals 0 is not in the x range, we do not offer an interpretation. Okay, so if x equals 0 is not in the x range, we may not offer an interpretation for the y-intercept. So I don't care what that b is, 37.08. If the test or if the x equals 0 does not check out in the range, we cannot offer an interpretation. Now let's say if x equals 0 is in the range, which is not the case in our particular example of foot traffic, we offer an interpretation for, okay, if x equals 0 is in the range, we offer an interpretation for x equals 0 and the b value. Okay? Let me let you finish writing that. And if you have colors, because again, I think it makes sense if we can show the colors. I'm going to do the same thing that I did before so you can see where this is coming from. Let's see if I'm going to change this to red. X equals 0 is in the range because see this x equals 0 is this one. It's this 0 right here. That's the check. That's the check we're trying to see if x equals 0 is in the range. Then this comma b, all right? Again, this x equals 0 is not in the x range. We may not offer an interpretation for the y-intercept. If this x equals 0, I'm just going to do these colors so you can see, is in the range, we offer an interpretation x equals 0, which is this one here, and the b value there. In other words, I just don't want you to think that this x equals 0 is coming out of the blue. You're saying, wait a minute, why are you thinking about this x equals 0? Because the y-intercept looks like 0, comma b. So I have to interpret the 0 and then interpret the b. Now, so in your notes, if you want to, you can go ahead and write something like a statement, something like since. So this answers the question in this particular problem. So we'll say something like this. Since x equals 0 is not in the range of foot traffic data, comma. Since x equals 0 is not in the range of foot traffic data, which I circled earlier, is not in the range, we not offer an interpretation. Okay, so since x equals 0 is not in the range of foot traffic data, we may not offer an interpretation for the y-intercept. We may not offer interpretation for the y-intercept. So now we need to figure out, well, what it is in the range, like what do you say? But is everybody follow me in terms of why we cannot offer one in this particular problem? It's almost like saying like, well, I won't even go there, right? What I want to do after this, imagine 0 was in the range and try to figure out like what to do with that. But like in an exam problem like this, the first thing you do is check to see if x equals 0 is in the range. Now, when you're given a set of data, like when will 0 ever be in the range, right? Well, it's possible. It's possible. Like if we were doing a study on what number of hours a student studies and grade, it's possible for a student not to study like 0 hours of study. And so that 0 technically would still be in that range, right? Let me show you here. Is everybody okay with just this general explanation? Like I can give you a set of data that looks similar. Oh boy. It looks like this. Hours studied, oh, I don't know, I'm just making this up. 5 hours studied, 3 hours studied, no hours studied. So if this is your x column here, then now x is in that range now. So in other words, it's like it's the lower end, right? So from 0 to 5, which technically means it's in that range, right? Or now, I know this isn't possible, but think about a set of data that may have something like this. You don't have the 0, but you have something like a -2. Just follow me here. You really can't have a -2 hour study, right? But imagine we had a set of data where you don't see the number 0, but do you see how if I'm given a data set like this, do you see that 0 is still in that range? Does that make sense? Right? Because you have a negative, like think about a number line, like -2, -1, 0, 1. You see how the lower number is -2 and the higher number is 5. You see how 0 is still in that range, although you don't see the number 0, right? But then other times, if that -2 is not there, and you literally have that number 0, then this is fair game now to interpret the y-intercept. Because it's not only is it in the range, but it's the endpoint. It's like the lower value. So I just want to clarify that. Even though it may not necessarily be in the range, it could be one of those low values or high values there. All right. Okay. So now let's struggle and let's imagine. Let's imagine. We're going to imagine in that foot traffic data, just change one of the values to 0. Right? And we're just going to assume that we're still going to get 37.08. So assume that when you do the check, foot traffic, the values there were 29, 49. Just imagine one of those values is 0. I know it's not. And we're going to act like our B is still going to be the same number. How do we now interpret the y-intercept here? So if you follow my logic, even though it's not true, So here's how we would do it. We're going to say y-intercept interpretation. Y-intercept interpretation. All right, so imagine x equals 0 is in the range. What we have to do, okay, 0, 3708. 0, 3708. 0, 3708. This is x, this is y. In our problem, x equals foot traffic, y equals sales. X, y. X equals 0, y-intercept. We have to do something like this. When there is no foot traffic which one of those does that deal with up here in these two numbers? When there is no foot traffic represents X. You see how when I say there is no foot traffic, that's essentially saying X equals 0. You see that, right? So the first step when I'm interpreting the y-intercept is to bring some kind of understanding in terms of what X equals 0 means in the context of the problem. If X is foot traffic, X equals 0 for foot traffic means there is 0 foot traffic, or there is no foot traffic. So I have to interpret this part here, 0. When there is no foot traffic, sales are expected to be what? Sales are expected to be what?
0, right?
Well, we dealt with the 0 right here. So we're finished with the, and then now we move on to sales. Sales are expected to be what? So which one deals with sales? Which one of these deals with sales? Yeah, the 3708, right? So when there was no foot traffic, I dealt with this part right here. Well, this is the Y here, which is sales, 3708. Sales are expected to be $37.08. Okay, so just take a look at that. Take a look at that. Again, we're kind of suspending our disbelief. We're assuming X equals 0 is in fact in that range. So what we have to do is say, when there is no foot traffic, when there's nobody coming into your store between 1 and 2 o'clock, that's X equals 0, then sales are expected to be 37.08. Notice the difference in the language. When we interpreted the slope, when we interpreted that Y, we said sales are expected to increase by $7 and whatever 14 cents, right? So in other words, it's increasing by. Whereas here, the interpretation of the y-intercept, I'm not saying it's increasing by 37.08. I'm saying the sales are expected to really be $37.08, right? So you understand the difference there, right? So here is the interpretation of 0, the X part, and then here is your B right here, this number right here. Okay, so this is just a model to kind of follow when in fact you've gone through the check of making sure that X equals 0 is in your data range. But in our real life problem, we couldn't do it in the real life nature of our real problem because X equals 0 was not in the range. So I just wanted to equip you for whichever situation you're going to be in. Either you can interpret it or you can interpret it. If you can interpret it, this is kind of, it's real straightforward, Figure out what X and Y are, and then say something about X equals 0, foot traffic, or when students do not study at all, X equals 0 in that case, the grade is expected to be, oh, I don't know, 40 or something like that, I don't know. But that's how you interpret those right there. And any questions? And I think you'll get the hang of it once you continue to do problems. I think you're going to have a problem today where you're going to have to sort of know how to do that. That's look on page 329 in the book, page 329, 330, 331. Yeah, well, really 330, 329 and 330. Where it says interpreting the y-intercept and slopes. If I didn't do a good job in explaining that, just read that at your leisure, because it's pretty much telling you everything we kind of just did. Now, we won't worry about if there's like 3 or 4 numbers involved in that. We'll get to that later, like something called multiple regression, but we're just dealing with the fact of MX plus B.